Alrighty guys, welcome back to our YouTube channel. So today we're going to be reviewing a bunch of skills that we've learned over the last couple of weeks involving polynomials. So for each of the problems, what you should probably do is just pause the video, and then when you come back after you've worked through the problems, you'll see the worked out solution. So go ahead, pause the video, copy down the problem, and the instructions say to match each item on the left with each item on the right. So we're going to be doing some matching, and then this in red right here is asking for the degree of the term above it. Okay, and then for B and C, we'll probably have to be a little more specific. So for B, let's look for the degree. Yeah, so we're just going to look for the degree of that polynomial. All right, guys, so welcome back. Okay, so if we're going to be matching, then it looks like B has two terms, so then that would be a binomial. A has one term, so that would be a monomial. And C has three terms, so that would be a trinomial. Remember, these are three different terms in that expression. So those count as, that's why we call it a trinomial. Okay, and then let's look at the degree. Remember, the degree is the highest exponent that you see in the polynomial. So for A, the degree is 5. For B, the degree is 3 because I've got this cubed here attached to that x. And then for C, the highest exponent I see is here, that is with that 2, so that's squared. All right, and that takes care of number 1. All right, so for number 2, the instructions say that we want to use the zero product property. So we're going to use the zero product property in order to solve for x in all of these. So go ahead, hit pause, copy down the problems, and try them on your own. All right, guys, welcome back. So hopefully you have the solutions worked out, and then we can go through the answers together. So for number 1, to get x by itself, we're going to divide both sides by 3. 0 divided by 3 is going to be 0. So the solution for number 1 is x equals 0. Now for number 2, we're going to start off by dividing both sides by 4. So I'm left with x minus 6 equals 0 divided by 4 is 0. And then to get x by itself, I'm going to add 6 on both sides. So then here for number 2, the value of x is 6. All right, and then for number 3, we're going to start off very similar to number 2. We're going to divide both sides by 7. Bring down 2x minus 9. 0 divided by 7 is 0. Now to get x by itself here, I'm going to add 9 to both sides. And then I'm left with 2x equals 9. And to get x by itself, finally, I'm going to divide both sides by 2. So here, x equals 9 over 2. Okay, and we should practice leaving our answers as improper fractions because they'll be helpful to you guys as you go through your math careers in high school. Okay, if you wrote this as a decimal, you could have gotten 4.5, and that's okay too. Okay, now for the last one, it's written in factored form. So to use the zero product property, remember we're just going to set both of these terms equal to 0. And we're going to solve. So for this first one, x plus 1 equals 0. To solve for x, I'm going to subtract 1 on both sides. And I get x equals negative 1. And then for the next one, I'm going to add 2 to both sides to get x by itself. And so for this one, I get x equals 2, and that's my solution. Now for all of these, I can go ahead and plug in my values for x, and I should get a true statement. So for example, in number 1, if I plug in 0 in for x, well, 3 times 0 is 0, and that's a true statement. For number 2, if I plug 6 in, I get 4 times 6 in for x equals 0. 6 minus 6 is 0. So I get 4 times 0 equals 0, and that's a true statement. Okay. And you're going to get a true statement for number 3 as well, and then the same thing for number 4. But let's go ahead and double check number 4 because that looks a little different. So I'm going to go ahead and plug in negative 1 wherever I see an x into that expression. Okay, so negative 1 plus 1, that is 0. Negative 1 minus 2, that's going to get us negative 3. And then 0 times negative 3 is 0, so it's going to give us a true statement. And now let's go ahead and double check our second solution, the solution of 2. So I'm going to plug in a 2 wherever I see an x. So 2 plus 1, and then 2 minus 2, does that equal 0? Well, 2 plus 1 is 3. 2 minus 2 is 0, and 3 times 0 is 0. So that is a true statement. All right, let's go on down. to number 3. So again, we're going to solve using the zero product property, but it looks like for these, you're going to want to factor. Now, it looks like these are differences of squares. So if you need to, pause this video, go back and re-watch the video on difference of squares, then solve for the variable. Hit pause, and when you come back, we'll work through the solutions together. All right, guys, welcome back. So if you went ahead and rewatched that video on zero product property, we know that if we've got difference of squares, this first term is a perfect square, and the second term is a perfect square, and the difference means we're subtracting the two, which we are. So when we go to factor it, we get x plus 5 and x minus 5 equals 0. Now remember to use the zero product property. I'm setting each of those factors equal to 0 and solving. So for this one of my solutions is -5. When I add 5 over here, the other solution is going to be positive 5. Okay, so those are my two solutions. For number 2, w squared is a perfect square, 144 is a perfect square, and I'm subtracting them, so we're following differences of squares. So my factors are going to be w plus 12 and w minus 12 equals 0. And when you solve for w, your solutions are going to be w equals -12 and w equals 12. It's not one or the other, guys. Both of those are your solutions. You need both of those when you're writing your answer. Okay, and then for the last one, just go ahead and switch colors over here. So is this first term a perfect square? Yes, it is. Is the second term a perfect square? Yes, it is. So what's the square root of 9y squared? Well, the square root of that is going to be 3y. So we're going to put 3y in the first spaces in both of those factors there. And then the square root of 16 is 4, so we're going to go ahead and do that. Set it equal to 0, and set both of these factors equal to 0, and we're going to solve. So subtract 4 on both sides, and I get 3y equals -4 divided by 3 divided by 3. So one of your solutions is going to be -4/3, and your other solution is going to be +4/3. Okay? So I think we've got one more to do here. Oh, no, we've got 2. All right, so for this one, we're going to find the greatest common factor. Now remember, when we're finding the greatest common factor, we're looking for the things that both of the terms have in common. So what can I divide both of those things by? So the greatest common factor of number 1, well, let's see, I can divide both of those numbers by 5. And then how many x's can I take out? I have 3 x's here, but I only have 1 there. So what that means is I can only take out 1 x. So that's my greatest common factor. Now, when I rewrite my expression, remember, I'm going to divide both of these things by the greatest common factor. And that's then we're going to factor our expression. So the greatest common factor is going to come out here. That minus sign is going to come along. Alrighty, so 5x cubed divided by 5x, well, that's just going to be x squared. Okay, and then 10x divided by 5x, that's just going to be 2. So this is your factored form. Okay, and then for number 2, greatest common factor. All right, let's go through the same thing. So what can I divide -28 and 7 by? Well, you can divide both of those things by 7. And I have 4 x's over here, but I only have 3 x's over here, so I can take out a maximum of 3 x's. So that's my greatest common factor. So if I rewrite that, I have 28x to the 4th plus 7x cubed. We're going to divide both of those things by 7x cubed, divide both by 7x cubed. Okay, and we should get 7x cubed because that's our greatest common factor. So over here, 28x to the 4th divided by 7x to the 3rd, that's going to be -4x. And then 7x cubed divided by 7x cubed, that's just going to be 1. Now, if you decided that your greatest common factor was actually negative 7x cubed, that is okay. We're just going to have some sign differences here. So if that was your greatest common factor, then your final answer should look like this. Okay. Both of these answers are a-okay to have. All right, and let's do one more practice round. So for this one, we're going to factor the trinomials and then solve for x. Okay, so if we're factoring the trinomials, remember, we're like Miss Gilroy said, we're going to be looking for two numbers that add to that middle term and multiply to the last term. So I like to set up mine like this. So we want them to add to 8 and multiply to 16. So if I'm making a list of numbers that multiply to 16, I know that 2 and 8 multiply to 16, 1 and 16 multiply to 16, and then 4 and 4 multiply to 16. Which one of these pairs adds to 8? The only pair that does that is 4 and 4. So that's going to be, those are going to be our two factors. So go ahead, set up our parentheses, x plus 4, x plus 4, 4 equals 0. And then we solve. So it's the same factor that we have. So when we solve for x, we get x equals negative 4. All right, and then for the next one, we want two numbers that add to negative 1. Remember, there's a negative 1 there. And multiply to 6. So let's think of numbers that multiply to positive 6. Well, 1 and 6 do, and 2 and 3 multiply to 6. And then negative 1 and negative 1 and negative 6. Whoops, there's a typo here, guys. This should say minus 6. My mistake. Okay, let's keep going with our factors. So that means negative 1 and positive 6. Or we can say negative 6 and positive 1 multiply to negative 6. Or negative 2 and positive 3. Or positive 2 and negative 3. So which ones of these pairs will add to negative 1? Well, 1 plus negative 6, that's going to equal negative 5. So that's not my pair. Negative 2 plus 3 is positive 1. That's not a negative 1, so it can't be this pair. Negative 1 plus 6 is positive 5, so it can't be this one. 2 plus negative 3, that's negative 1, so that's going to be our pair. So we're going to go ahead and plug that in. So that's x plus 2, x minus 3 equals 0. And so then when we use the zero product property, subtract 2 here. So one of our solutions is x equals negative 2. The other solution is going to be 3. So x equals 3. And we are done. Don't forget to like, subscribe, and comment down below, guys.